Good morning. If you do not know me already, my name is Josh Buchanan, the Mechatronics Robotic Specialist at your local SMC. We encourage posting any questions that you may have in the chat or wait until the end of the webinar for contact information to contact me directly or to contact the team through SMC's website via a QR code. First, we'd like to thank you for joining us today here to learn how a few of Rockwell Automation's tools can enhance your design processes, improve collaboration, and optimize your factory operations. In the next few minutes, we will bring you up to speed on how you can add virtual commissioning and simulation to your digital design. You can enable real-time data insights for improved decision making and simplify and streamline your design workflow. What we're going to do today is we're going to cover what is digital engineering, why does digital engineering matter, give you some tools to implement the digital engineering into your operations. We're going to hear from our special guests, Dan Ratcliffe, Shayla George, and Mike Amendola. And after that, we'll close it from there. Before going anywhere in today's presentation, I would like to first define digital engineering. One of the things that is most important to recognize is that there's no singular definition of digital engineering. Google around and you'll find that it means something different to everyone and can be expressed in so many different ways. I define digital engineering as an intentional approach to leverage tools, processes, and information to develop and implement projects and solutions, and then to support these developments throughout their life cycle using the available data intelligently. A couple questions I have for you. What if you could evaluate manufacturing options to meet business goals quickly? What if you could leverage digital tools to empower employees to do their jobs? And lastly, what if you can implement projects faster? Well, if any of those interest you, you're in the right place. And we'll show you how to do that here in the next few minutes. Why digital engineering? Well, it all starts with speed. Digital engineering accelerates the design and prototyping processes by enabling virtual simulations, rapid testing, and real-time adjustments. This minimizes the need for physical prototypes, significantly shortening developmental cycles and allowing companies to bring innovative products to the market faster. But speed alone isn't enough. Accuracy is crucial. Advanced simulation and modeling tools ensure that designs are precise and optimized before they are physically implemented. By catching potential issues early, businesses can reduce errors, costly redesigns, and downtime, leading to more reliable and high-performance results. With greater accuracy comes significant cost savings. Virtual testing and predictive modeling drastically reduce expenses associated with physical prototyping and trial and error testing. By identifying potential challenges early in the process, companies can avoid costly mistakes and streamline their operations. Efficiency is further amplified through seamless collaboration. Digital engineering connects teams across engineering, design, production, and operations through a unified digital platform. With everyone working from the same data, collaboration becomes more cohesive, eliminating silos and important overall project execution. Real-time insights also play a crucial role in driving continuous improvement. Digital engineering provides instant access to critical data on system performance, process behavior, and operational status. This empowers teams to make informed decisions, proactively addressing issues, and optimizing performance at every stage. But what happens when the market shifts? Businesses need the agility to adapt quickly. Digital engineering allows for rapid modifications to designs, helping companies stay flexible in the face of changing customer needs, market conditions, or regulatory demands without costly delays. At the same time, optimizing resources is key to efficiency. Digital engineering enhances resource allocation across design, production, and operations. By identifying inefficiencies early, businesses can minimize waste, maximize resource utilization, and improve overall system performance. Risk mitigation is also a top priority. Virtual simulations allow organizations to evaluate scenarios and test solutions before implementation. This proactive approach mitigates risks, ensures that potential issues are resolved before they impact operation safety or cost. And let's not forget sustainability. By optimizing designs through digital modeling and simulations, businesses can reduce energy costs, energy consumptions, waste, and carbon footprints. Digital engineering supports sustainability efforts by enabling more efficient processes that minimize environmental impact. Finally, digital engineering fuels continuous improvement and innovation. With digital twins, real-time data, and advanced analytics, businesses can constantly refine their products, systems, and processes. This cycle of ongoing optimization ensures that they remain at the forefront of innovation, scalability, and long-term success. For some basic background, this slide was pulled from the State of Smart's manufacturing report. The report is a collection of customer feedback that highlights the major forces in manufacturing around both the technology advancements and trends, as well as the customer challenges. I felt this graphic was valuable because it highlights the main challenges that manufacturers face, with the top three focusing around skilled workforce, technology, and innovation. As a whole, manufacturers are struggling to innovate because it is so challenging to find a workforce that can adopt new technologies. Many facilities are stuck using old discontinued equipment because it's what people there know. The trickle-down effect of this is that it's more difficult for manufacturers to leverage assets and the data within their assets to make quick and informed decisions about their processes. All of this is leading for a need to more openly embrace new technologies, but also doing it in such a way that allows for the maximum amount of flexibility to adapt to changes on the plant floor, whether that's how the machine adapts or how the overall product demand and mix change. All of that comes back once again to the idea of workforce and labor challenges as a contributing factor to risk. It's important to note that embracing new technologies is the top response for mitigating and addressing some of those previously mentioned risks. And it's not just about buying the parts and pieces, but more about how we can use it to address the needs of the current manufacturing climate while also creating considerations for the future. Presented on these slides are many ways to help mitigate the previous risks, but it also comes back to the idea of adopting new technologies, whether that's the infusion of AI into the field devices to augment some of the maintenance practices, or utilizing on-machine I/O to improve the troubleshooting response. Sorry. As a distributor, we can't necessarily staff your facility for you, although we do have the lengthy list of trainings. What we can do is provide you a pathway to mitigate some of these risks through our technology offerings and support. The top three barriers are cost, expense, lack of skill set to implement, and lack of skill set to optimize. We understand that cost concerns and an inexperienced workforce can make adopting new technology feel like a challenge. That's where we come in. With our expertise and experience, we'll partner with you every step of the way to ensure a smooth transition and help your team get the most out of the new technology without adding unnecessary strain to your resources. Together, we'll make it manageable and successful. The digital twin created by using Emulate3D mitigates the risks and adds flexibility to your projects. It helps improve your project timeline and the quality of the design while reducing hardware dependencies and commissioning risks. As you can see here, with a digital twin schedule compared to the traditional schedule, we test the system virtually while working on the system, mechanical, and control system designs. This allows us to cut out some time for physical testing and rework, leading to savings. So some of the tools that we have here and to implement this digital engineering in your operations would be one, Emulate3D. Emulate3D will be used to add virtual commissioning and simulation to your digital design. FactoryTalk Echo is used to enable real-time data insights for improving decision making. We'll not go much into this on detail, as we wanted to inform you more about the other solutions with our time today, but Echo is a great tool for emulating a PLC instead of relying on the physical PLC to grab this data. And FactoryTalk Design Studio Copilot will simplify your streamline your design workflow. From here, I'd like to hand it off to Dan Ratcliffe so he can talk a little bit about Emulate3D for you.
Dan, you're on mute.
I apologize. There we go. Thanks for your time today. My name is Dan Ratcliffe. I'm responsible for Emulate3D commercial aspects for half of North America. And my job really is to support your local sales teams there, your local Rockwell sales team, and more importantly, your local distributor teams as well. So, Josh, as we talk about Emulate3D as a digital design tool, we really we like to start by reviewing some of its primary use cases and really how it's applied throughout manufacturing, the entire manufacturing design cycle. So when you take a look at early phases, right, of a project where you may just be starting to lay out what the equipment looks like, you've got pillars and columns and everything else. So having a 3D environment that you can really do that in is key. And that's one of the aspects Emulate3D can do. We'll get into more of the details here in a couple slides, but the ability to actually, lay out a line, to take a look at some throughput analysis, really at a high level before you may even know what the tooling is going to look like. And imagine if you could, see that visually, right? Not just looking at Gantt charts, not just looking at Excel sheets, but to have a kinematic 3D model to view that concept. And that same 3D concept really can be applied through taking a look at the machine at a station level or even a cell level, but not just looking at the mechanical aspects of it, but bringing in the ancillary equipment. You could have operators, you could have robots, you can have independent cart systems, as you see here. So the ability to bring those in a visual environment, to really have all your stakeholders take a look at that and agree that that's what the process is and that's what it's going to look like. And Emulate3D can help you there as well. Continuing on with that model and in the same software, really from a virtual commissioning standpoint. So, we've thought about a design, we've come up with a concept, we've validated that concept, we've really optimized, shall we say, that process. The ability to take a look at bottlenecks, right, before we start to build the equipment in the real world is key. But then, all right, we're ready to go, but commissioning always takes time. So a use of the software really is what we consider virtual commissioning, and the ability to commission your system, all your controls testing, your PLC testing, right, your HMI testing, integration with all the other equipment ahead of time. It's an opportunity for your controls engineers to really do a deep dive and troubleshoot those areas of their responsibility without having to sit on a plant floor waiting for production parts or pre-production parts. We actually have customers that are end users that are no longer providing prototype parts. So they're only giving you digital parts. So it's really difficult to test out, shall we say, a real system with digital parts. You really need a digital equipment to do that with. And that's Emulate3D can support that as well. And then I'll let you just think about other uses, right, of this digital twin, shall we say, or the digital replica. If I can use that for operator training, I have a complete digital environment with VR. I can immerse people into that environment. Maintenance personnel can take a look at access to equipment, how you may want to do, equipment changes, equipment repairs, and imagine doing that in a very safe environment, right? There's no lockout, tagout required, but you can certainly use it to train on lockout and takeout. Or even operator training, right? Imagine having an operator already trained on the equipment before that equipment is even started up. The whole goal really is to speed that time to value. Digital engineering helps accelerate that design environment. Virtual commissioning helps you shorten and accelerate and move off the critical path, your commissioning, and then even training operators ahead of time is all key. So what does the software look like? Well, Emulate3D really is one aspect of the Rockwell's digital ecosystem. It really is an environment that's self-contained. We have catalogs of items that you can build. I'll show that in the next slide. But you can really build on that as well. So being a great product out of the box, there's also ways to expand its use. And we have customers that use it, as we say, strictly for demonstration purposes, all the way up through, virtual training cells. So Emulate3D is that product that, as we talked about, having VR and AR for training. You can expand, shall we say, the fidelity of a model and actually go from simulation to emulation. So simulation to us is when all the behaviors inside the model, shall we say, the model is self-contained. Things are moving around, things are acting and reacting just based upon logic inside the model itself. From an emulation standpoint, we really just have a piece of digital equipment. And that equipment sits there, just like real equipment on the plant floor sits there until it receives, outputs from a PLC, and then it generates inputs to the PLC, and then the PLC does that logic to make it work. So you can take your PLC program, download it into a physical PLC, or as was briefly mentioned, Factory Talk Echo product, which is an emulated PLC. And use that to drive that digital twin, to drive that digital replica, all in the safety and comfort, right, of sitting at your desk while you're doing that debug. So you can we have catalog items, again, as I'll show you in a minute, but you can actually enhance that model by bringing in your own geometry. So part of that, your mechanical folks have done their digital transformation. They've thrown that data into the digital pipeline or the digital thread, and now Emulate3D can receive that digital data, and you can bring in that geometry and add the kinematics to it. So that's how you get that visualization of a kinematic model moving and acting. In addition to that, if I'm going to be doing true virtual validation, right? I need to validate that my schematics are correct, my wiring is correct, my push button panels are correct, right? So it's not just validating your PLC program and your HMI program, but also your schematics to make sure everything is connected correctly, shall we say. Again, all with not just the mechanics of the equipment moving, your robots and your operators and your tooling and your conveyors, but also the product itself. So you can see that product moving down through the line. Emulate3D is really focused on discrete manufacturing within the four walls of a plant. And those types of processes, discrete processes, we have equipment for. But the software is expandable. If you have other types of processes, being free-flowing liquids or gases, if you want, you can continue to expand the fidelity of your model through our functional mock-up interface. So we support FMI. We'll be here in the next month with the new release coming out. And then if you have a process model, shall we say, in MapleSim or MATLAB or ANSYS, this is a way that you can incorporate a reduced order physics of that model, apply it inside Emulate3D. So again, from a commissioning standpoint, not just verifying the mechanical connectivity and electrical connectivity of the equipment, but also how that is responding to the process if you want. We like to say that Emulate3D really allows you any level of fidelity from a visualization standpoint, a behavior standpoint, and from a connectivity standpoint. And then if you really want to expand that, right, we have connectors to Omniverse. If you want to do total scene orchestration, really if you're familiar with NVIDIA's Omniverse, it's a really nice collaborative 3D rendered environment for digital equipment. And we support that either live connections or even post-processing with Emulate3D files. So Emulate3D really can help you through that whole design cycle, even from sales, from a demonstration standpoint. We talked about simulation, being able to have a physics-based simulation engine, which is key. So it doesn't have to be physics-based, but again, if you want that higher fidelity, you can. The beauty of having the physics-based is in most simulation environments, discrete event simulation engines, the visualization really is just a graphical representation, shall we say, of the empirical data. But in Emulate3D, an object moves from point A to point B. If it's a load going across a conveyor, it moves because that conveyor has an acceleration, it has a max speed, it has a deceleration. If I stretch that conveyor, it's automatically going to take longer if I maintain the same speed for that product to get from point A to point B. So it's a very nice 3D environment that you can lay items out and then use that data from the physics of the environment in your simulation. And then we've talked about from virtual commissioning. What does it look like a little bit from the product? And we'll just touch on it here, but by all means, we can certainly deep dive into more detailed conversations and product review. Just reach out with your local distributor there, and we'd be happy to set that up. But the system itself, really from a system design standpoint, right? The ability to drag and drop. So we have catalogs of items that we have an online library of catalogs. We have robots, we have AGVs, we have ASRS systems, AMRs. And the whole point is to be able to quickly lay out and to demonstrate a process without having to write a lot of code. So in this case, this video is sped up a little bit, but you can see that we're not creating code anywhere. It's a drag and drop, cut and paste, shall we say, of predefined catalog items. Those catalog items have the visual here, but they also have the behavior built in. So we talked about that from a simulation environment, that the behavior is already there. So on a conveyor, you can say that you're just going to turn on and you're going to run. If the conveyor has a photo eye attached, you're going to say, hey, you're going to run until my part hits the photo eye, and then you're going to stop. So it's a very easy way to put a concept together and to share that concept either with internal stakeholders, so your mechanical folks, your process folks, your controls folks, your maintenance, your operators, but also with customers, right? If you want to share a concept with a customer, being able to share that in that 3D environment. And there's a lot of things that you can, catch, shall we say, and see in that environment. We actually had a funny story. A plant manager, customer was showing their layout, shall we say, to the customer, and they actually went to the detail and added the plant layout and the plant floor as a DWG, shall we say, on the bottom of this. And the plant manager was not happy because he had a conveyor running right across the window of his office that was on the second floor. So again, having that 3D environment just brings that clarity to the whole operation. From a optimization standpoint, that's where you can really bring in the Sim 3D level that allows you to run experiments, take a look at where you might have bottlenecks. We talked about any level of fidelity visually. This is an example here. We don't know what the tooling looks like yet. But we're just laying out the process and we're optimizing the process. So we have catalogs of black boxes that in this case, we just have different processes, right? Different buffers, different process times, and you can run all kinds of scenarios there. If you want, then you could slowly replace this buffer with what a conveyor buffer would look like, and you can mix and match black boxes with higher fidelity graphics as to what the equipment might look like as you go through that. So imagine the ability to, verify your OEE, right? Improve that quality the first time, reduce the unplanned downtime, right? You can build in here, if you have empirical data with your MTBF and MTBR data, mean time between failures, you can put that in here just to see what the total throughput would be. And then you can try different scenarios, right? Well, what happens if I run a parallel line here? Is that going to get me the throughput that I need? Is that where my bottleneck really is? Do I need more testing stations? So the ability to drive those improvements. The nice thing is, for new systems, you can do this ahead of time, but you can actually use the software to model existing systems, and then apply all your what if scenarios and see which of your scenarios are going to get you, better throughput for equipment that you may already have on the floor. So you can see here, this is the same, shall we say, the same dashboard you can have, but really more from a physical environment if you want to see that. And there's lots of details behind this. You can run it in with the graphics off. You can run it faster than real time. You can run days, weeks, months of information through the model to see how it's going to perform in a very short period of time. And then our other aspect we talked about was virtual commissioning, and just to imagine the ability to have your PLC program either in a live PLC, a physical PLC, or in this case, a virtual PLC with Factory Talk Echo, but the ability to, again, drive that model, validate your PLC code, validate that all the mechanics are going to work together. Imagine doing this ahead of time, right? I started my career as an old controls engineer and spent lots of time in plants, right? Waiting for skilled trade operators to help me if I just needed to move a limit switch a little ways to see if it was going to operate properly. Here, it's a 3D environment, right? I can move the switch, make sure that that's what's going to work. And it is, the technology today is at the point where it is the physical equipment. It is the physical robot, or physical replica, shall we say, of that robot, graphically and mechanically correct, kinematically correct. We had a owner of a company that was just ecstatic because his controls engineers were able to be home over the holiday because they were able to start up, shall we say, or commission a line a lot faster in the real world because they had done it virtually ahead of time. The ability to do it in that safer environment. And then again, so we have that model. Imagine, right, really using that for operator training, either in a fully immersive environment, in the case of virtual reality, right, or the ability to we went forward slide, or the ability to actually do that just in the 2D environment, right? It's I say 2D environment, it's a 3D model inside a 2D environment, but we have the ability to record videos. So you can imagine recording a video and training an operator. This is the actual HMI virtually displayed in the model. And again, fully emulated with all the schematics, hitting your e-stops, making sure everything's going to work, doing your safety buy-offs ahead of time in a much safer environment. That's really what, I'll just leave you with that, right? The ability to have that digital replica of your actual tooling, and imagine having that with you on your desktop, right? And be able to remote troubleshoot, do deeper dives of troubleshooting. So it really is that, the ability to accelerate that time to value, right? In this case, this is the actual contactor line that Rockwell moved into their offices in Milwaukee, and they built a full model of that line just to verify the process, verify that it was going to fit in the location, verify that all the options could properly be taken place, verify all the controls debug. They debugged all that ahead of time so that the line started up really quick. So you can see that, having that digital machine really in that collaborative environment is can be key to accelerating that time to value. And of course, right, going back, none of this would be possible without digital transformations, without digital threads of the data being there, without the digital equipment. So that's really what, to sum up, right, the value of what digital engineering gives us. And with that, I'm going to pass it back to Josh.
Yeah, thanks, Dan. As you guys can see here, that Emulate3D is, plays a huge role in the digital engineering. It's the backbone of that digital engineering solution there from us here. Next, I'd like to hand it off to Shayla George to kind of talk about how we can make it easier on our customers here with Factory Talk Design Studio and Copilot.
Thanks, Josh.
Yeah.
So good afternoon, everyone. My name is Shayla George. I am a software and controls technology consultant. So I am the technical resource for our sales teams. Today, I will be talking about Factory Talk Design Studio. So what is Factory Talk Design Studio? This is a cloud-based environment for industrial automation design. It was built from the ground up to be new and existing only in the cloud. And so when I say cloud, what I mean by that is that the product was built to run exclusively in Rockwell Automation's public cloud, which we call the Factory Talk Hub. And it's able to provide a software-defined experience for system design. Before I go into detail about Factory Talk Design Studio, I thought it was important to kind of give you an idea of, where it sits inside of our portfolio. So as I mentioned, Factory Talk Hub is Rockwell's public cloud. And so this is where we are providing products to customers, delivering them all together in one single environment. So it's not something that you buy. Again, this is a cloud-based product, and it's combines all of these, the software and the products inside of the cloud. And inside of Factory Talk Hub, you will see that there are 3 different areas, and we have different softwares that fit in each of these areas. So you'll see Factory Talk Design Hub, which is the area that we'll focus on today, where Design Studio fits in. There's also Factory Talk Operations Hub, as well as Factory Talk Maintenance Hub. When you click on the Design Hub, inside of the Design Hub, you'll see the products that live here today. So at the top, you can see Factory Talk Design Studio, as well as some additional software such as Optics, Twin Studio, Factory Talk Vault, and Remote Access. But the idea is that all these products exist in the same space and they can share data in an integrated experience. So you might be wondering what makes Factory Talk Design Studio different from a product like Studio 5000 Logix Designer. And that's where we'll go a little depth into that. And so what you see here is we call these the 3 M's, modern, multi-user, and multi-controller. By modern, what we mean is that with Design Studio, we're bringing modern software development workflows into industrial automation. So if you think about things like object-oriented programming and integrated management to libraries, this is what you can do with Factory Talk Design Studio. Additionally, from a modern standpoint, with Design Studio, you don't have to worry about managing software. So there's no need for you to download, install, or activate any software. And there's no need for you to manage any type of software updates. So any software patches with Studio 5000, you don't have to worry about those inside of Factory Talk Design Studio. With Design Studio, because it sits in the cloud, you'll always be working with the latest and greatest. And what sets it apart is that, with our traditional on-prem software like Studio 5000, there's typically a yearly release cycle. With Design Studio, we are doing quarterly updates, and sometimes these updates are more often than quarterly as well. From a multi-user standpoint, what we mean there is exactly what it means, right? How it sounds. That is, we want to be able to provide tools to our customers that will allow multiple people to work simultaneously. So when you think about where you have a team of people that are working on the same project, and you want to be able to have a simpler way for you all to share files and work on certain pieces of the project, Design Studio enables this. It also enables you the ability to bring people with different skill sets together in the same environment. So some of the things that this also brings is the ability for you to track project changes. So seeing exactly who made what change, when, where, and what time. So you'll be able to better manage that. You can also manage the roles that each person has. So with Factory Talk Design Studio, there is a role-based access control where an administrator has the ability to assign roles to different users, and these roles could be administrator, engineer, technician, things of that nature. And then lastly, multi-controller. Again, sounds means simply how it sounds. But what this is being able to manage and configure multiple controllers all in the same project. So if you think about Studio 5000 Logix Designer, that project, it's one controller per project. And but with Studio Logix 5000, we want to be able to go beyond that. So what we have here is that you can have all of the controllers you need in your system to be programmed in one single project. So those are the 3 M's that we use to describe Factory Talk Design Studio: modern, multi-user, and multi-controller. So before we kind of jump into, as I mentioned, there are quarterly updates. And before we jump into what the most recent updates were, I just wanted to, give you a quick look at what the roadmap looks like. So as I mentioned, the exciting part about the SaaS-based products is that we have the ability to be able to update frequently and more often. And also you always have ability to or access to the latest and greatest version of Optic Studio without having to manage this. What you see here, these are, just some of our past updates that we had 2023 and 2024, and then our latest update, version 2.0, which came out in January. This is where highlights what was delivered there, and we'll dive a little bit in depth to that. But before I do that, I also wanted to share some of the things that are coming up on the roadmap. So in the bottom right corner, what you can see under the coming up, there's things such as structured text editor, being able to connect Logix Designer to other software like Factory Talk Optics, the integration or the introduction of safety controllers into Design Studio, as well as shared libraries and online editing. So you will see that there is no date that is listed for these. That's simply because it's on the roadmap, but we don't have a defined date that I can share. But one thing I would suggest doing is that you can always frequently check our coming soon section on the web page to see what is coming up next. So now we will kind of jump into the 2.0 updates. So as I mentioned, 2.0 was released in January, so last month, and it was a big release for the Factory Talk Design Studio program. What you'll see here on this slide is that we have delivered AI-powered design that can generate, explain, and troubleshoot code using simple natural language prompts. You'll also see that we also have the ability to deliver the technology from in a secure connection from cloud to controller communications. So now, previously with Design Studio, it will require you to, once you develop the application in the Design Studio, you would have to convert it to an ACD file and then open up Studio 5000 Logix Designer to be able to download that file to the controller. But with version 2.0 of Design Studio, we now have the capability of going directly from the cloud to the controller, and we'll talk about a little bit about how that's done. And then also, with the 2.0 release, we've also enabled the end-to-end workflow of being able to design, deploy, and do online monitoring of devices in your automation system. Okay, so first we'll talk about Design Studio Copilot and the integration of Copilot. So the use of natural language prompts with the integration of generative AI has enabled the product guidance, project guidance, as well as project creation. So with product guidance, what this is, it gives the ability to accelerate onboarding by guiding new users through product features without external help, and simplifies troubleshooting by helping users understand and resolve errors quickly. So what this does is it uses Copilot to generate responses from the online help as well as error code documentation. So what that means is users can have prompts like, what are the new features that are available, what devices are supported, or how can I create a routine? And then Copilot will generate a prompt in response to those questions that were asked. With the project guidance, this enhances system understanding by delivering project insights in a no-code environment, so eliminating the need to navigate complex logic programming. So this gives customers the ability to get an understanding of what is going on in a project. So when you have customers that are dealing with legacy PLC code and those with new PLC or that are new to PLC programming, they can benefit greatly from this because Copilot has the ability to explain complex programming logic and give a summary of different pieces of the code inside of Design Studio Copilot. And then lastly, the project creation piece of it. So the project creation piece automates system development by using natural language prompts to model systems and generate PLC code. So again, Copilot can help you configure a system by using pre-built AOIs, programs, and routines. So for instance, you could essentially say, create a block of code that has a motor and it starts the motor running at a specific speed at this time, and Copilot will be able to generate that code. Additionally, it'll provide a system summary of how that code is supposed to be supposed to respond. So like comments and things of that nature. The next piece or the next addition with version 2.0 of Design Studio is the cloud to edge communication. So the lines between OT and IT continue to blur, increasing the connectivity between digital and physical part of our operation. If you're designing your automation system in the cloud, how do you get your project out of the cloud and into your controller? What about being able to monitor it online and troubleshooting? And how is that done securely? So if you look here, this is achieved through the utilization of FactoryTalk Remote Access. So FactoryTalk Remote Access is Rockwell's remote access solution that gives you that ability to remotely access systems. And remote access also sits inside of FactoryTalk Hub as well. So if you look here with Design Studio, you have the ability to deploy code to multiple controllers at the same time using FactoryTalk Remote Access. And then in addition to that, you have that ability to monitor and test your code online while working on the next phase of the project. And I know a lot of people wonder about the security aspect of FactoryTalk Remote Access, and it is developed with IT compliant cybersecurity in mind, and it has the fundamental security features and functionalities that follow IT standards and policies. And that, I will hand it back over to Josh.
Yeah, thanks, Shelley. We keep making success easier, and I appreciate that. There's a lot of great information that you gave us there. Next, I kind of want to show, show what SMC and how SMC and Rockwell kind of collaborated to get ahead of the curve here and show you what we've done there. So I'm going to give it over to Mike Amendola to kind of talk about our demo video here that showcases what we've done there.
Awesome. Thanks, Josh. So as Josh said, my name is Mike Amendola. I'm a mechatronics technology consultant with Rockwell. And I want to show this demo here. This is a mechatronics demo showcase that we have. SMC had decided not so long ago that they wanted to develop some kind of mechatronics demo to showcase the capabilities that SMC and Rockwell have with our unified robotic control and our independent cart technology, the foundations of mechatronics that we have at Rockwell. And so what you're seeing in this video are two Kamau robots that are utilizing our unified robotic control, which is simply to say we can take those Kamau robots and we can control them with Rockwell PLCs and Rockwell servo drives, kinetic servo drives. So you don't need a separate robot controller. You don't need knowledge of how to program robots in particular. You just need a foundation of ladder logic in order to do this. And you also see down there our Magnamover Light intelligent conveyance system. This is part of our independent cart portfolio, which allows for intelligent conveyance through the movement of linear motion with magnetics and linear servo motors. So SMC came to Rockwell, came to myself, and said we would like to build this demo to have in our new office in Springfield, Missouri. And so we utilize these digital engineering tools. We utilize Emulate3D to import the CAD, to import the robots, to design the track, lay it out, verify, and do all of the verification that this demo is going to meet the needs of what we wanted to showcase, be able to show all of the important functions and features of Emulate3D or of the robotics and the mechatronics stuff. So we used Emulate3D to do this. And then afterwards, we decided to take Emulate Echo, FactoryTalk Logic's Echo, and we began to do virtual commissioning. So as Dan had said earlier, we were able to utilize Emulate3D and FactoryTalk Logic's Echo to do virtual commissioning on this system, verify our pick and place points, verify that the track was going to function properly, and test out our code and do code generation as well from that. And so once all of that was complete, we went and we built the demo that is now located in Springfield, Missouri. And so, Josh, you can, if you want to stop sharing, we could take a look and see, and you'll see the actual demo running live right now on a camera from Springfield, Missouri. So this is the demo that you were just looking at within Emulate3D, within that video. And this is the live version of that demo. So we took the digital twin and we created a physical twin. You'll see we have the two Kamau robots there that are running on unified robotic control, meaning they have a Rockwell PLC running them, the same Rockwell PLC that runs the rest of the system. And they are running with the kinetic servo drives. And you'll see our Magnamover Light, our independent cart technology down there. So as the pucks are getting sorted, those hockey pucks are getting sorted between the red and the blue, or the blue and the white. The robots are picking and placing and recirculating them around. And if you look behind there, you'll see the TV screen that has the digital twin also showing on there, running in synchronicity with the physical twin. So with that, I wanted to mention that this demo is in Springfield, Missouri, and you can schedule some time with SMC. And I'm going to hand it back to Josh to finish things up. And thank you all for the time.
Yeah, thanks, Mike. So we'd like to, finishing things up here. We'd like to thank you for joining us today as we explored the powerful advantages of integrating Emulate3D and FactoryTalk Copilot into your operations. These tools aren't just technologies, they're enablers of smarter, faster, and more efficient design making for your organization. Together, these solutions form a cohesive ecosystem that helps your company embrace innovation, improve productivity, and stay competitive in an ever-evolving industry. We hope this webinar has provided you with valuable insights into how these tools can address your unique challenges and drive your business forward. If you have any questions or want to dive deeper into how these solutions can be tailored to your needs, please don't hesitate to reach out to our team. You can reach me directly at the email and phone number listed above, or scan the QR code that will take you directly to our website where you can request specific information by email. Thank you once again for your time. We look forward to helping you take the next step towards digital transformation.